Hello and welcome to this video that is going to demonstrate the appropriate way to draw a rise-run triangle when asked to compute the slope of a line that connects two points, or in fact when you're just given a line. Okay, so I'll start here with this example, these two examples where I'm given 2 points, and when you're dealing with just 2 points, it kind of begs the question, well, which point should you start at? Should I start at this point, or should I start at this point to draw the triangle? Well, a habit that I would like my students to develop is start on the one that's furthest to the left. Okay? It's going to help you learn to read in a left to right fashion, which a large percentage of the time is going to help you just be more efficient because it's kind of how your brain is already trained to read. There are circumstances you have to read right to left in math, but for right now, let's use this idea of trying to read left to right and calling that sort of the normal mode of our reading. Okay, so I will start at this point, and very simply, I am going to draw a rise ray, okay, which here you see extends 2 grids up. I label it with a 2, and then I'm going to draw a run, which is going to be 2, 3, 4 grids. And if you notice, when I label that, I can put in this last piece of the triangle, which in fact represents the line segment or line that connects the 2 points, and that is what I am in fact computing the slope of. So that rise-run triangle would allow me to say I have a rise of 2 and a run of 4. Therefore, I have a slope of 1/2 or 0.5. Okay, in this next example, again, I'm going to try and use this general rule of starting on the point that's further to the left, which is, in fact, the one I just showed you. And I will draw my rise, which is an odd word because in this case my rise is moving down, -1, -2, -3, -4, -5 grids. Very important to get our signs right. It makes sense that down is negative, up is positive, left is negative, right is positive. Okay, and then I'm going to draw the run component here of this triangle, which you'll see is 3 grids. In the positive direction, I'll label that with a 3. And again, drawing this final component of just the line segment, or the line that would connect these 2 points to make the triangle, is in fact what I'm taking the slope of when I draw that rise-run triangle. So you see in this example, I've got a rise of -5 divided by a run of +3, which in fact just gives us a slope of -5/3. Okay, so now let's move on to the examples where we're just given a line. Now, the only part here that's a little more confusing than this previous example is when I'm given a line, I'm given an infinite set of points. So which points should I pick? Okay, now you theoretically can pick any 2 points on the line, but this would be a bad one, and so would this. If you notice about those, they do not intersect on grid marks. Okay, so you want to look on the actual grid mark intersections because those are the only ones you could legitimately say the distances between when you are drawing the rise-run components. Okay, so I'll take any 2 points that intersect grids nicely, and I'll say I like this one. Also, if you notice it's on the y-axis, you'll see throughout the unit that that's always a good one to pick if it's available. And now, trying to use my left to right reading, I'm going to go up on this line from left to right, which is going uphill, and then I see I have a point right here. First intersection of a grid that looks nice is this one. Okay, so again, we're going to start between these 2 points on the one further to the left. So that is going to give me a rise of 1 and a run of 3. So the slope of this line could be expressed by rise over run of 1/3. It can't be simplified, so you would just say 1/3. Okay, now in this second example, again, we would be looking for 2 points on the line. We notice that the y-intercept here is not a very nice point, so I won't be using it. So I will look along the line and see where I have grid intersections. It seems like I have one here. And you can pick any two that you want. Okay, so now I'm going to move from that point uh, in kind of left to right fashion, which means I got to go downhill. And I'm looking for the next grid intersection. It looks like it's right here. Okay, so which point do I start at? Again, the one furthest to the left, which is this one. So I will do, in this case, a negative rise. So -1, -2, -3. And I'll label that as such, followed by a run of +2, which then gives me a rise-run triangle that represents a rise of -3 and a run of +2, making the slope -3/2. Okay, so I hope that demonstrates how to appropriately draw rise-run triangles. Again, they're just graphic organizers for us to express and organize our thoughts when computing the slope between 2 points or the slope of a line, where you would have to first select 2 points.